When we learn something, it's encoded in our short-term memory first, then it's moved to long-term memory if your brain thinks it will be needed for longer. But it turns out that there are large individual differences in people's ability to learn new information and then retrieve it again later. For example, try to remember that this type of pasta is called fusilli. Decades of research have led to the discovery of a series of mathematical equations that can serve as a computational model for human memory and learning. When we know how someone learned a fact, like the Spanish word for apple, we gather information like the specific time the fact was introduced, the times that person has been tested since then, their prior knowledge on the subject, and relatively how difficult that fact is for people to learn in general. We can then predict the specific amount of time it will take for a person to forget that fact. Every time you think about a fact, you increase its activation in the brain. And through more repetition, this activation lasts longer. So every time a person thinks about the meaning of apple in Spanish, this activation has spiked. Because of this, the model takes your reaction time into account. If you've ever tried to remember something that was on the tip of your tongue and it took you a little while to think of, you know that it takes longer to access memories that have a lower activation. And if you know something very well, you can answer questions about it quickly and easily. So the model uses your reaction time to estimate a fact's current activation level in the brain. So do you remember the name of that pasta? If you said fusilli, you got it right. It's been exactly 1 minute and 14 seconds since it was introduced, and according to our model, it should have been forgotten by now. Though if you were rehearsing it in your head, you probably didn't forget it. Cheater. But if you're just that good and you actually did remember it, then the model now knows that it underestimated how well you would remember that fact. It then slightly updates the information that it uses to calculate when you'll remember that fact and other new facts in the future. Through an 8-minute task where we constantly introduce new information and analyze it when a person forgets it, we can obtain a model that is quite predictive. Once this happens, we have a good idea of a person's individual speed of forgetting. This is a measure that's been demonstrated through our research to be a relatively stable and reliable measure of how fast you'll forget learned information. We're using this technology in all kinds of exciting ways. If kids in school need to memorize lots of information, we can reintroduce it at the brain's most efficient time for optimal learning. Right now, we're developing the use of speed of forgetting as a measure of tracking memory decline in early onset Alzheimer's patients with some very promising results. This technology has a wide range of application in everyday life, and it's changing all the time to become more and more accurate.